Hey, welcome back. Today we're looking at 211, polynomial end behavior. So before we start talking about end behavior, we have to understand what the degree means, and this is a review from Algebra 1. So the degree just means the largest exponent, and when we're talking about end behavior, we're looking at just that term with the largest exponent on it. So what end behavior means is we're looking at what happens to the function as we approach negative infinity to the left and infinity to the right. So they behave pretty much like, so an even degree, meaning that we have an exponent that's even, looks kind of like a parabola from quadratic functions, where if our leading term is positive, then we have our function rising to the left and the right. If it's negative, just like a parabola is, then we'd have it falling to the left and the right. Now, for odd degrees, these behave like cubic functions or even linear functions. So if we have a linear function whose leading term is positive, then we have falling to the left, rising to the right. And then if we have a negative one, then it does the opposite. So it rises to the left, falls to the right. All right, so these are just terms that they're using to describe our end behavior. So let's kind of go ahead. This should be pretty simple. So we're trying to determine the end behavior for these three functions. Excuse me. So again, when we're looking at end behavior, we're looking at the leading term, the one with the highest degree. So our highest exponent, excuse me. So this one is degree 4, which is even. And then the leading term sign is negative, and then it's negative. So if we go back here, 4 is an even and it's a negative, so our end behavior would be, we're looking at the evens and a negative, so we're falling to the left, falling to the right. So falling left and right, and if you want to draw it, you'd rather draw it, then it looks like this towards the ends. Okay, second one, same thing. We're going to look at the highest exponent. So this is degree 5, which is an odd. And then our leading term is negative. So if we go back here, we're looking at an odd, negative. So this one rises left, falls right. So rise, left, fall, right. If you rather draw it, then it looks like this towards the ends. Now, number 3 is a little bit different because it's in a different form, right? We have the parentheses, we have the squareds going on here. So let's talk about how we'd determine this one. So one thing to do would be, we could multiply this whole thing out, right? We could square this, meaning we do 3x minus 5 times 3x minus 5, and then multiply by the x squared. But the easy way to do it, just because we're only concerned with the leading term, is we're going to take this number, right? And because we have the leading number, right, 3x, the biggest term in there, and because we have a squared on it, we're going to square it. So that would give us 9x squared, because 3x times 3x is 9x squared. And then we have this outside part, x squared times 9x squared. So when we multiply that together, our leading term would be 9x to the 4th. So we're running off this 9x to the 4th now, and we're doing the same thing. So we're looking at the 4. This is an even. And then our sign, okay, so, and our sign is 9, right? So this is going to be a positive. And then if we go back here, we're looking at the even, positive, so rise, rise. So this is going to be rise, left, and right. If you would rather draw it, then it looks like that.